Hey, what is up guys, and welcome back. So today we're going to be taking a look at the Foxeer Aero Mini Pro FPV camera from Foxeer. Now this is running a CCD sensor, so keep that in mind. Unlike the CMOS can have better latency, and I'm very curious to see how this one's going to perform. Usually CCD cameras perform around the 15 millisecond latency, which is still pretty good. But lately we've been seeing those CMOS cameras hitting under 5 milliseconds, which is actually just pretty much amazing. So we're going to be testing that today. Now the current one I have here is the PAL, and I've noticed PAL to be slightly faster, which is kind of weird. Usually NTSC would be faster, but in a previously tested Foxeer, the PAL was actually faster, but it was just by 0.2 milliseconds. However, this is slightly different, and again, because it's a CCD sensor inside. So let's take a look at some of the things it comes with before jumping into the latency testing. Now, if you're expecting video quality footage, that will not be here. You're not going to be able to see its video quality just yet. That'll be an upcoming video. So some of the things they do provide you with is an adapter or the metal bracket here to mount this if you needed to mount it to something specific. Also, the size of the camera, you need to take note of this. This is not a micro nor HS1177 size camera. This is a mini, which is right in the middle. However, what they do is they provide you this adapter, which you connect to it, and now it will take the size of an HS1177 type camera, so it would fit most frames out there. Also, they give you the cables needed here, the OSD menu buttons, if you needed those, and just some rubber gaskets, and as well as some screws and stuff. Now, if we take a look at the back here, we see that it has a VSense port, and the VSense is meant to measure your battery's voltage in case your quadcopter or your airplane didn't have some kind of OSD to give you your battery reading. You can actually sense it through here. It has a specific port right there on the side called VSense. So that would go to your positive of your battery basically. So it can give you an idea of how much battery you have left, and this way you won't fall out of the sky because you didn't know. So that's something really nice right out of the box. It's using the same type of standard connectors that all cameras are actually been using, so that's really nice also, and it's to be expected, especially from Foxeer here. So enough talking, let me prepare everything and let's start testing its latency. Alright guys, so we're going to test the latency with the LED turning on as well as turning off. Usually when the LED is turning off, we get a lot more latency. So let's go ahead and get started here. Now on the top row here, we have the video signal coming in straight from the camera to the oscilloscope. And on the bottom here, we see when the LED turns on and off. So as you can tell, when the line goes up, that means LED on. When it just went down like that, it's off. So it's on and off, as you can tell. And you can see that in the video feed. And we're just going to calculate the difference, and we'll know the latency from each. So let's go ahead and take our first sample with the LED turning on here. All right, so let's go ahead and take our first sample here. Okay, and we're going to zoom in here. Now, as you can tell, this is actually looking pretty interesting. As you can tell here, it started to notice the LED that it turned on, because the LED turned on all the way back here. But to fully actually know that the LED is on, it's all the way to here. So this is going to be kind of trivial of how you want to read this. But currently, this is not really looking pretty good. That's 36.6 milliseconds. But if you wanted to go on this frame here, this half a frame, that is 16.6 milliseconds, which is okay, but you're actually seeing it around 30 milliseconds, which is, it will affect your flying. I can tell you that right now. And I'm really hoping when the LED turning off, we don't get an increase in latency, because usually all cameras do increase in latency, and we'll see that in a bit. Now, if you're wondering what are these lines that are sticking up all the way right there, those are actually the OSD information. So this would be the odds of the OSD information, the odd lines, and this would be the even lines of the OSD information, because it's all the way on the down right corner, or just on the bottom of the screen, and that's what you're seeing right there. That's just the OSD information. So if we actually disable the OSD, we wouldn't see these lines anymore. All right, let's go ahead and take another sample here. Hopefully we can get a better sample. All right, and again, it's catching it on the second frame, just slightly, which is 15.4 milliseconds. But to fully actually have it in the video signal that the LED is completely on, that is 35 milliseconds. This is the no-go zone in latency if you're flying a quadcopter. In an RC airplane, it's not going to really matter that much, because you're just cruising in the air, and you know, a quadcopter, you need, you know, every single millisecond not to crash into a pole, especially if you're racing. So this one is looking like it's possibly one of the worst I've tested so far. I mean, the what is it? The Runcam Split S has better latency than this. 34 milliseconds. That is pretty terrible here. And if you want to go to this little frame here, which is 14.2 milliseconds, but you're actually still seeing the change at 34 milliseconds. So that's not doing really great so far. Let's go ahead and jump over to the LED turning off here. So we're gonna do that real quick. So here's another sample. Okay, so this is kind of strange, because usually it increases, but LED turning off here, is around, I'm just going to move this up slightly so I can see the reading. So as you can tell, the LED with the LED turning off, we're getting 11.5 milliseconds here. So let's go ahead and take another sample and see what we get. Alright, we're just going to zoom in here. And it's also just about the same, 10 milliseconds. So with the LED turning off, it's doing better, but still, it still has quite a lot of latency. 10 milliseconds here. 10 milliseconds is good, but you know, there shouldn't be that big of a fluctuation between them. And it could be the wide dynamic range that is currently on the CCD camera here. So it's 10 millisecond, pretty consistent in LED turning off. But you know, with the other CMOS cameras that I've been testing, the difference was anywhere between 0.2 of a millisecond to 1 or 2 milliseconds, not a full 20 milliseconds of difference, which is yeah. So this one is a bit of a strange one, I would say. There's stuff that obviously that is a lot better in the market, and personally I would not put this on a quadcopter. If the picture is awesome and quality is great, I'd probably put it on an RC airplane or something that I'm not going to be flying very fast with, and that I need every second of latency or every millisecond. So in terms of latency, this one is really a no-go, to be honest. That's just as honest as it gets right here. I personally wouldn't recommend it. It's not a bad camera, but if you're on a quadcopter, I wouldn't put this on my quadcopter, basically. So yeah, it's 8.8 milliseconds here with the LEDs turning off. So keep that in consideration. And there's really nothing else I could say about this camera. So I really hope you guys enjoyed the video. If I did help you make a purchase or avoid a purchase, please consider using the links down below. You don't even have to purchase the same thing in the link, and or help me on Patreon. That'd be absolutely awesome. And I really hope you guys enjoyed it. Let me know what you guys think down in the comment section, and I'll see you in the next one. Peace out, guys.